All right, guys, let's finish up our do now. Come back together. All right, number 1 on the do now, we are turning 7.34 times 10 to the 7 into a standard number. Someone raise their hand. Tell me what they got. Go ahead, Alessandra.
7,347.
Tell me in numbers as opposed to the word.
7340000.
How many zeros?
5.
5 zeros. Perfect. Yes. And that number is 73,400,000. Yes. So because we've got this 7, it's positive. We're moving our decimal point to the right 7 spaces. And that gives us 734 followed by 5 zeros. Number 2, 7.34 times 10 to the 9. Go ahead, Victoria.
734000000.
How many zeros?
7.
7 zeros. 1, 2, 3, 4, 5, 6, 7. Yes, that one gets 7 zeros because we need to move this over 9 times to the right because it is a positive exponent. Number 3, let me hear from someone else. Number 3, who's got an answer? Kim, go ahead.
0.40734.
Perfect. Yes, because it is a negative exponent, we are going to the left 5 spaces, and that gives us a decimal point followed by 4 zeros, 734. What about number 4? Alondra, go ahead.
2 zeros and 7.
Awesome. Yep, this one we have to move -3, which means we're going to the left 3 spots, and that gives us 0.00734. For the last half, we're turning standard form numbers into scientific notation. Raise your hand if you can turn 3,456,000 into standard form. Richie, go ahead.
3.456 times 10 to the
Nope, not 3. Let's count it together. So it's right here. We're going to move it so that it's next to the 3 and the 4. So we're going to go 1, 2, 3, 4, 6. Yep, so it's 10 to the 6. Remember, when we're turning big numbers into scientific notation, it's always going to have a positive exponent. Next one. What did we get? Go ahead, Victoria.
3.456 times 10 to the 9.
10 to the 9, right. I think you didn't say it, but there is that decimal point between the 3 and the 4, so that it's scientific notation. And yeah, we've got to move that decimal point over 9 times. And once again, we're turning a big number into scientific notation, which is a positive exponent. Now we've got little numbers. What is this one going to be? Go ahead.
3.45. I didn't know. 3.456 times 10 negative 5.
10 to the -5, perfect. Our decimal point's over here. We want it right here, and we've got to go over 1, 2, 3, 4, 5 times to get it there. Last but not least, Edith, how would you help us out?
3.456 times 10 minus 3.
Yep, to the
minus 3.
perfect, to the -3. Now we've got to move this decimal point over 1, 2, 3 times. While everyone is finishing up on their do now, can I please have Alex read us the objective? Students will be able to
use initial value
and
rate of change to create a function.
Yep, it got a little erased. I'm sorry about that, Alex. So we're using initial value and rate of change to create and graph a linear equation. That's that word that was erased for some reason. Cool. Let's all turn to page 3. We've got one I do, so voices are going to be off. We've also got this lesson summary. Can I have a brave student read me the lesson summary? Go ahead, Kim.
When the rate of change B and initial value A are given in the context of the problem, the linear function that models the situation is given by the equation y equals A plus B.
Perfect. This should look familiar to us. We sometimes see this as y equals mx plus b, or it can be y equals b plus mx. Go ahead, keep going, Kim.
The rate of change and initial value can also be used to stretch the graph of the linear function that models the situation.
Perfect. Rod, can someone please give me the synonym we've been using for rate of change? What's that other word we've been using for rate of change? M. Perfect. Or slope. What about initial value? What letter do we give to initial value? B. Yes, thank you. All right, when two or more ordered pairs are given in the context of a problem that involves a linear relationship, the graph of the linear function is the line that passes through those points. The linear function can be represented by the equation of that line. Number 1, on the I do, a truck rental company charges a $150 rental fee in addition to a charge of 50 cents per mile. Graph the linear function relating the total cost of the rental in $C to the number of miles driven M on the axis below. Someone help me out. When we see the word per, are we going to give that number an M or a B? We see per. M, yeah, per, we're thinking slope. Whereas the other one is going to be our B, it's our initial value. So if we go down to A and are asked if the truck is driven 0 miles, what is the cost to the customer, i.e. what is our initial value, we're going to say that B is equal to 150. And that, of course, gives us the point 0, 150. So when it says how is this shown on the graph, that's our y-intercept. What is the rate of change? We already talked about that. That is our M, and that is 0.5. Explain what that means within the context of the problem. Well, if you're renting from this truck company, they're going to charge you 50 cents per mile. On the axis given, sketch the graph of the linear function. So we've got a B of 0, 150. Our slope is 0.5. Can someone help me out? What is 0.5 written as a fraction? 1/2. Awesome. So we always like our slope written in a fraction form is going to help us to give us our directions. So from this point, we're going to go up 1 and over 2. Up 1, over 2, up 1, over 2. Once we've got enough points, we're going to take a straight edge or a piece of paper, and we're going to graph the rest of that function. Everyone understands what I'm doing here? I'm pulling out where the problem might be. I'm pulling out my slope. I'm using my B to graph a point and using my slope to get us from one point to another to finish off that graph. In letter D, we're asked to write the equation of the linear function that models the relationship. Well, we know that y is equal to mx plus b. We figured out our b was 150 and our m was 0.5. All we have to do now is plug those values into this equation, and we get y is equal to 0.5x plus 150. Make sure everyone has that written down. Any questions so far as to where I'm getting these numbers, how I'm putting them into this problem? We've been working with y equals mx plus b form for about 2 months now, so I think everyone should be pretty comfortable with it. No questions? Okay, let's move on to page 4. We've got one we do problem. Then the rest of the packet is for you guys to work on your own on. So stay with me while we go over this one together. Let's have Edith read us this problem.
Jenna bought this car for $18,000. She has been told that the value of the car is likely to decrease by $2,500. For each year that she owns the car, let the value of the car in dollars be and the number of years Jenna has owned the car be.
Perfect. So usually we've been using x and y. In this case, our y is going to equal v, and our x is going to equal t. So instead of y equals mx plus b, we're going to have v is equal to mt plus b. Because let the value of the car in dollars be v, and the number of years she owned be t. Letter A, what is the value of the car when t is equal to 0? Someone raise their hand. What is the value of the car when t is equal to 0? Go ahead. 18,000, perfect. That's the initial value that she paid for this car. So our B is equal to 18,000. That gives us a point to graph. What is the point that we can graph? Something, comma, something. What's the point we can graph? Something, comma, something. Go ahead, Richie.
0 and 18,000.
Perfect. Yeah, remember our B, you can see it up here. Whenever we have our B, we are given the point 0, comma, B. So 0, comma, 18,000 is going to be that point right there. What is the rate of change in the context of this problem? What is the rate of change? Be very careful. We need some volunteers. I'm going to start calling. Alessandra, what is our slope for this problem? No. Nope, so we've already used 18,000. The only other information we have is that she has been told that the value of the car is likely to decrease. What should we do with that decrease, though? Negative. Awesome. Yeah. So for every year she has this car, it's going to be worth even less. So this slope is negative because it'll never be worth more than $18,000. Write the linear function. Remember we said v is equal to mt plus b. So m is equal to what?
Negative 2,500.
Perfect. And b is equal to?
18,000.
18,000. So Richie, what is our b equal to? Plug in m and plug in b.
B equals negative 2,500. plus B,
Which is?
which is 1A18.
Awesome. To make this answer look a little nicer, I'm going to move some things around thanks to the additive identity. This is going to be 18,000 minus 2,500t, just to get that minus out in the front. In letter D, we're asked to fill out the table for the value of her car t years after she bought it, with t equals 1, 2, and 7. This means we're going to be finding 18,000 minus 2,500 times 1, 18,000 minus 2,500 times 2, and 18,000 minus 2,500 times 7. All right, I want everyone to take 30 seconds. My far row, you guys are going to find when the value of the car is 1. My middle row, you guys are going to find when the value is of t is 2. And this row, you guys are going to find when t is equal to 7. Take 30 seconds. 30 seconds. I'm going to be walking around, making sure everyone is finding out the value. Columbia. All right, everyone. Take a couple more seconds. Find out what the value is going to be. All right, I've seen some great work. Keep going, guys. All right. Someone who found number 1, tell me what the value of the car is after 1 year. Go ahead.
15,000.
15,000. No, not quite. We're missing one number. So this is going to be 500. Yeah, so this is going to be 18,000 minus 2,500, and that's going to give us 15,500. Alex, go ahead and tell us what the answer was when t was equal to 2.
13,000.
13,000, perfect. We just had to multiply 2,500 by 2 and subtract that from 18,000. And let's see here, Victoria, give us number when t is equal to 7. 500, perfect. Taking those values as coordinates, we're going to plot those points. So we've got over to 1 up to 15,500. Over to 2 up to 13,000. Over to 7 up to 500. We're going to connect those dots, try to make it as straight as possible. So after 7 years, is her car really worth that much? No, right? We can see that pretty much after 7 years, her car is going to be worth 0. At that point in time, she pretty much should just like sell the parts. All right, now we are going to take 5 minutes to work on the first you do problem on our own with our voices off. Then we're going to come back together, go over the first one, and do that same process for the last 2 ones as well. Go ahead, turn your voices off. I'm going to be walking around, making sure everyone is on task. Go ahead. Voices are off. We're working on our own.